So here the topic is quantum tunneling. Okay, this is a fascinating phenomenon in the field of quantum mechanics. I think you might have heard this phrase, quantum tunneling. You know the meaning of tunnel. So here in this case what happens, say for example there is a tunnel and inside the tunnel there is one barrier. And you are walking through that barrier and there is one obstacle in your passage. There is one obstacle and you have to overcome that obstacle. So in your body you should have sufficient energy to overcome that obstacle. You can consider the obstacle to be a mountain. Okay. Similar thing happens here. But in case of tunnel and your body, means you are walking through the tunnel and you need sufficient energy to overcome that barrier that is crossing the mountain. You have to go other side of the mountain. So if you don't have sufficient energy, it won't be possible for you to overcome that mountain. But in case of quantum mechanics, similar things happen. There is one obstacle and the quantum particles, means fundamental particles such as electrons, they need to overcome the barrier. In spite of having less energy, means the kinetic energy of the electrons, if it is not sufficient to overcome that barrier, here the barrier is termed as potential energy required to overcome that barrier. Or it can be expressed this way also, say a minimum energy required to overcome that barrier, which is known as here potential energy, and you need to have that much of energy, minimum that much of energy, and here you means I am talking about electrons. So if electrons are not having that much of energy, means that much of potential energy, is it possible for the electrons to overcome that barrier? But in case of quantum mechanics, means in case of classical physics, it is not possible to overcome that barrier. Say there is one ball, okay, and the ball needs to roll up the surface of the mountain and it needs to go other side of the mountain, okay, and if the ball has not sufficient kinetic energy, then it won't be possible for the ball to go other side of the mountain. But in case of so this is for classical mechanics or classical physics. So our classical intuition says like this. But in case of quantum mechanics, it is defying the classical intuition. In spite of having less energy of the electrons, experimentally it has been found that electrons can easily overcome that potential energy barrier. And this effect is known as quantum tunneling in the field of quantum mechanics. So what is the cause behind this? You know, in quantum mechanics you might have studied wave-particle duality. Yes, normally electrons are considered as particles, but it has wave nature also. And due to this wave nature, there is a probability of finding the particle anywhere in the space. Okay. So due to this probability, the probability is positive here. This phenomenon, quantum tunneling, becomes possible. Yes, of course, there is one limitation. Limitation is there. But since the electrons are having wave nature also, and due to this wave nature, there is a probability of overcoming that potential energy barrier in spite of having less kinetic energy. as compared to that potential energy barrier. There is a probability, and it has been found experimentally that yes, it is true. So wave particle duality, that was the first point to be considered here, and next was barrier penetration. So I have already mentioned this topic, that is barrier penetration. Yes, there is one limitation. Depending upon the thickness and height of the barrier, we can decide whether overcoming that barrier is possible or not. Means penetration is possible or not. Means if you can overcome that barrier, then we will say that penetration has become possible. Penetration of what? Barrier. So this is termed as barrier penetration. Okay. Next point is exponential decay. Yes, depending upon the thickness and height of the barrier, okay, if thickness is too much, if height is too much, then you will observe experimentally that there is exponential decay of the probability of that electron or fundamental particle, means quantum particle, to overcome that barrier. This decay is exponential. Still, due to wave-like nature of particles, there is a chance or there is a probability of overcoming that barrier, albeit very small. Okay? Means very small chance is there if thickness or the height of the barrier is too much. Okay? And so that was third point. Fourth point is applications. Here is there are numerous applications. You will find numerous applications of this effect, that is quantum tunneling, such as applications I have noted down here. Semiconductor physics. In the field of semiconductor physics, you will find the applications in case of nuclear fusion, in case of scanning tunneling microscopy. In case of nuclear fusion, you know that fusion reaction. Nuclear fusion reaction, it is known to you. So there is a strong repulsive force in the nucleus between the protons. So to overcome this strong nuclear force inside the nucleus of atoms, this quantum tunneling effect, due to this quantum tunneling effect, fusion becomes possible in spite of having strong repulsive force between the protons inside the nucleus. Okay, so you can see in the case of nuclear fusion, there is application of quantum tunneling effect, right? And in case of one more point was there, scanning tunneling microscopy. So in case of scanning tunneling microscopy, what happens, there is a metal tip, very sharp metal tip is there, and there is one surface, and the metal tip is brought in very close to the surface, and there is transfer of electrons from one part to another. And this becomes possible due to quantum tunneling effect. And accordingly, researchers can create the required image by using this effect, quantum tunneling. Okay. I mean, is there any other point? No. There is no other point to be discussed here in the context of quantum tunneling. Okay. There was a total of 6 points to be discussed in this case. Though this is very huge topic, okay, I have discussed in a brief this topic. So the purpose of this video, purpose of making this video was to explain to you the quantum tunneling effect. That is the focus of my lecture in this video. Okay, what is quantum tunneling effect? So once again, I want to say the same thing, that you know that if you have kinetic energy and using that kinetic energy, you can overcome certain potential energy barrier. If you have less kinetic energy as compared to that potential energy, it is not possible for you to overcome that barrier. But in case of quantum mechanics, this is possible, and this is possible due to the wave-like nature of the fundamental particles or the quantum particles, like electrons. Okay, and this effect is known as quantum tunneling effect, and it has numerous applications in different technologies. Okay, so this was all about quantum tunneling. Okay, thank you for watching this video.